Okay, so welcome back to the second part of this lecture. We're going to use the Ohm's law equation to answer a few questions. So as just solidify our understanding. Again, the Ohm's law equation states that V is equal to IR. Okay, let me just write that. So the electric potential difference, V, across 2 points in a circuit is equal to the product of the current and the resistance between those 2 points. Okay? V is equal to IR. So this question asks, which of the following will cause the current through an electric circuit to decrease? So the easiest thing to do is to rearrange it so you have current. So current, if you rearrange your equation, current high, remember that the current, the unit of current is the amp. So current is equal to V over R. Okay, so the current is equal to V over R. So which of the following will cause the current through an electric circuit to decrease? So looking at the equation, what will cause I to be less? You either have to increase R or you decrease V. Okay, so you're either going to decrease your voltage or you're going to increase your R. Just rearranging the equation and looking at it. So decreasing the voltage, yes. Okay, so this one is correct. So what about decreasing the resistance? If you decrease the resistance, it's going to increase I. It's going to increase your, so this is not correct. Increase the voltage, no, it's going to increase your current. Increase the resistance, that's going to decrease your current. So these two, so just looking at your equation, you can see, when you change one variable, you can see how it's going to affect the other. All right, so so question 2, let's erase this. Okay, a certain electrical circuit contains a battery with 3 cells. It has wires and it has a light bulb. So again, remember the battery is going to provide your electric potential difference. Okay, the wires is part of the external circuit, and the light bulb is what we call the load. Which of the following would cause the bulb to shine less brightly? Okay, so so if you decrease the current, it's going to cause the battery to shine less brightly. Okay, so let's look at our equation again. So you can write your equation, and okay, so the Ohm's law equation, electric potential difference is equal to the product of the current times the resistance across the load. Okay, so again, when we rearrange the equation, I is equal to V over R. So If you decrease the current, the bulb will if you decrease the current, the bulb is going to shine less brightly. If you increase the current, the bulb is going to shine more brighter. Okay? So you can decrease the current by decreasing the voltage and increasing the resistance. Okay? You can decrease the voltage by decreasing decrease the voltage of the battery, remove cells, or you can increase the resistance of the circuit. So those are things that will reduce the current and let the bulb will shine less brightly. Okay, so using the knowledge of electricity, you can manipulate it to get just what you want. All right. All right. So let's look at question 3. All right. So you have likely been warned to avoid contact with electrical appliances or even electrical outlets when your hands are wet. Okay. So when your hands are wet, avoid electrical outlets or appliances. You're always told that. Such contact is more dangerous when your hands are wet than dry, because wet hands cause what? All right, so you always go back to your equation, the Ohm's law equation. V is equal to IR. Okay, where I is the current, R is the resistance. I, that's current, is equal to the volts divided by the resistance. Okay, so if you're at home, then your standard outlet is going to be, say, 110, 120 volts. So this gonna be fairly constant for any home. But what happened if you are wet? If you're wet, it's going to reduce your resistance. So your resistance is going to be very, very small. Hence, the current flowing through you is going to be great, huge. So that is a problem by getting wet. It's going to reduce your resistance and increase the current that's going to flow through you. Okay? All right. So it causes your resistance to be lower and hence increase the amount of current that's going to flow. All right, so that's the correct answer there. All right, let's look at the other one. All right, if the resistance of a circuit were tripled, then the current through the circuit would be, all right, so, just write them out again. Don't rush it. V, this is your Ohm's law equation. V is equal to I, current, times R, resistance. So current, all right, so you don't have to write. So if the resistance of a circuit were tripled, so if this was tripled, the current would be what? Okay. So remember, if you have a circuit, this is going to be constant. The voltage is going to be constant. And if the resistance is tripled, okay, if this increased by 3, in order to keep the voltage constant, this has to be decreased by 1/3. So the current through the circuit would be 1/3 as much. So if if you take your household, if you take your home, the standard voltage might be 110, 120, fairly constant. But um, if you increase the resistance, if you triple the resistance, you have to decrease the current by a third in order to keep this a constant number. All right. All right. Let's look at the next question. All right. So if the voltage across a circuit is quadrupled, then the current through the circuit would be. All right. All right. So you just write your equation again. So V is equal to IR. Okay. And we know that I is equal to V divided by R. Okay. So if the voltage across the circuit is quadruple, so this increased by 4, okay? If you keep your resistance constant, if you increase this by 4, then your current is going to be increased by 4. So then the current through the circuit will be 4 times as much as well. Okay. Remember that the voltage is you can rearrange your equation and you can see how the current is going to vary with the voltage if you keep your resistance constant. Okay. All right. All right. A circuit is wired with a power supply. All right. A circuit always have to have an energy supply. It has a resistor ammeter. The ammeter reads 24 milliamps. Determine the new current if the voltage of the power supply was increased by. So again, remember that power is equal to VI, voltage times your current. So if your power is a constant number, if one increase, the other have to decrease. All right. So remember that power. We showed how this equation was derived. Power is equal to voltage times the current. Okay. So if the power is constant, then if voltage increase, the current has to decrease. Remember that voltage is in volts, current is in amps. So if you have milliamps, you have to convert it to amps, okay? And then, you just go through the rigors of working out what's going on. All right, so that's what question 6 is about. And then question 7, use the Ohm's law equation to provide numerical values for the following questions. So an electrical device with a resistance of 3, a current of 4 amps, an electrical device with a resistance of 3 ohms will allow a current of 4 amps to flow through it if a voltage drop of how many volts is impressed across the thing. So again, you're going to write your Ohm's law equation. V volts is equal to I, the current, times R, the resistance. So An electrical device with a resistance of 3, so R is 3, will allow a current of 4 amps, so I is 4, to flow through it if a voltage drop of, so it's 3 times 4 is 12. A voltage drop of 12 volts is impressed across the device. Always try and make sure that the units are the same, because the resistance have to be in ohms and the current have to be in amps. So always make sure that your units are correct. So when a voltage of 120 volts is impressed across an electric ether, a current of 10 amps will flow through the ether if the resistance is what? So you just rearrange the equation. Your resistance is equal to volts divided by the current. So if the volts is 120 and the current is 10, so it's 120 divided by 10, so you need a resistance of 12 ohms. 12 ohms. Okay? And then the third one, a flashlight is powered by 3 volts and uses a bulb with a resistance of 60 ohms. What will the current be? All right, so you just rearrange to get current. So we get current high. Current high is equal to volts divided by resistance. So the flashlight is powered by 3 volts, so the volts is 3, and uses a bulb with a resistance of 60. So that's 3 over 60. So 3 over 60, that is so that would be, so you just work it out and you get amps. So they want amps, they don't want milliamps. So it would be 3 divided by 60. Okay. So if you multiply this by 100, okay, you get 360 into 300, that is 5, and so it's you get 0.05. So it's 0.05 amps, okay? All right. All right. So just to sort of crystallize the knowledge somewhat. All right, so let's move on. All right. Okay, so these are circuits, and we're not gonna spend, I mean, you should have an understanding of how to rearrange the equation to get certain things. So use the Ohm's law equation to determine the missing values in the following circuit. So, you just use the voltage is equal to the product of the current across 2 points times the resistance. Just use that knowledge and you can answer the questions. All right, so let's move on. We're gonna discuss power in a little bit more detail. Remember what we said about electric power. When we talk about power in terms of electricity, it is the rate at which electrical energy is supplied to a circuit or consumed by a load. And of course, when we talk about a load, it's just any electrical device. So remember, your circuit is transporting electric energy, and that electric energy is gonna eat up your water. It's gonna, make the fan blow. It's going to cause the fan to spin. It's going to light up the bulb. So that electric energy is going to transform into heat, light energy, etc. Okay? But the rate, okay, the energy that is transformed per unit time is called the power. So energy per unit time is called the power. And what we showed before, that we show that power is equal to the voltage times the current. We derived this equation early on, okay? And we can use the fact that Ohm's law states that voltage is equal to the voltage across 2 points is equal to the current flowing between those 2 points times the resistance. And if we would just rearrange it, then current is equal to volts divided by resistance. So if we plug it in this equation, so V is equal to IR, so we just plug the V. So we'll get I squared, power is equal to I squared times R, where I is the current. And we can plug I, because I is equal to V divided by R. So if we plug I in right here, we get V squared divided by R. So right away, you can see that you can write power as voltage times current, or current squared times resistance, or voltage squared divided by resistance. So you can use all of these three equations to talk about the power in the units. And let's use it. So, all right. So the first question is, which would be thicker, which wider, the filament of a 60-watt light bulb or the filament of a 100-watt light bulb? And explain. All right. So which would be thicker? All right. Remember, again, when we talk about resistance, all right, let's just resistance is, we remember what we established. Resistance is directly proportional to the length of the wire, okay, and resistance is inversely proportional to the area or the thickness of the wire. So the greater the thickness, the less the resistance. Sorry, the greater the area, cross-sectional area, the less the resistance, correct? And the less the cross-sectional area, the greater the resistance. But that's not what they ask you. They ask you, you have two bulbs with different wattage, so different power. So, okay, so power, let's write out all the equations that we know. Power is equal to VI power is equal to I squared times R and power is equal to, so these are all the equations that we derive. Power is equal to V squared divided by R. So the lower the wattage, all right, so let's use this equation. Let's use, because we have voltage. I mean, assuming that you're talking about a household thing where the voltage is constant, then you can see that the power is going to vary inversely with the resistance. Okay? So the the greater the power, okay, so this light bulb has a greater power, okay, so for this number to be larger, you need a smaller resistance. So the smaller the resistance, the greater the power. To get a smaller resistance, you need a larger area. So the area has to be larger in the 100 as compared to the 60 because you have more power in the 100 watt bulb. So the more power, smaller resistance to get the greater power. Smaller resistance means a bigger area. Okay? So the 100 watt bulb are going to have the thicker or the wider wire filament. Okay? All right. So just using the equation to help us out. All right. Question 2. Calculate the resistance and the current of a 7.5 watt night light bulb plugged in to a US household outlet. In the US, it is 120 volts. Okay, so they want you to calculate the resistance. Okay, all right. So we want a power equation that has voltage and resistance. So we have 3 equations to choose from. All right, let's write them out again. Power is equal to VI and then power is equal to I squared times R. So I squared times R. And then power is equal to V squared divided by R. So divided by R. So we have resistance, we have power, and we have voltage. So we have to use the third equation. They want you to calculate the resistance of the resistance and the current. Okay, so first you can calculate the resistance. So they calculate the resistance and the current of a 7.5 watt night lamp, plug into that. So the power is 7.5, voltage is 120, and then you can calculate the resistance. So if you plug those in the equation, so let's plug it in the equation. So your resistance, so if you rearrange this equation, your resistance is equal to voltage square, okay, divided by power. So the voltage is 120. So it's 120 square. So 120 times 120. And you're going to divide by 7.5. The power is 7.5 watts. So you divide by 7.5. So that comes out to 1920 ohms. Okay. Remember, resistance is in ohms. So that's Okay, 1920 ohms when you do that. But you still have to calculate the current. But simple, you can now use your Ohm's law equation, V is equal to IR. So you know the voltage, you know the resistance. So voltage, so your 120 divided by 1920, that will give you the current. So current, which is equal to volts divided by the volts divided by resistance. So that will give you, the volts is 120 and your resistance is 1920. And that is equal to point 0. This is a 0. 6. This is a 6. 25. Okay. So it comes out to 0.0625. So, know all your equation for power, know your Ohm's law equation, and you can solve a lot of these. All right, so let's move right along. All right, so calculate the the resistance and the current. You have a much larger power, and again, so the same principle. Use the power. Use the equations for power. Get the resistance, then plug the resistance in the Ohm law equation, and get the current. All right. Okay, so this one, the box on the table indicates that the amperage. This is the current at startup is 15 amps. So we know. All right, so the current at startup is 15 amps. Okay. Determine the resistance and the power of the motor during this time. All right. So what we're going to do is see which equation we're going to use. So we know this is the voltage is 120, so you need to know that. Okay, so the voltage is 120 because the household, so the voltage is 120. All right. Voltage is 120 volts. So we have the amperage, which is the current at startup. Okay, so you're going to use your Ohm's law equation. V is equal to IR to calculate your resistance. V is equal to IR. Okay. Now, V is, all right, so resistance is equal to V divided by I. So resistance, rearranging the equation, resistance is equal to the voltage divided by the current. So it's 120 divided by 15. So that voltage is 120. Okay, that's your household voltage. If you're somewhere where the voltage is 110, you use 110. So at startup, that is the resistance. 120 divided by 15. 120 divided by 15 is 8. So at startup, the resistance is 8 ohms. Okay. So, and then, okay, determine resistance and the power. So they want you to determine the power. So you have you have multiple equations that you can use to calculate the power. You can use power equal to VI, the voltage, times the current. You have the voltage 120, current is 15, so you can use that. Or you can use V squared divided by R, or I squared divided by R. The simplest one is VI. So, you know, power is equal to VI. That's the simplest one. Power is equal to volts times the current. So it's very important to know your equations. Okay. So power is equal to VI. The volt is 120. And the current is 15. So 120, 15 is 1800. And that's 1800. And that 1800 is watts. Remember that power is in watts. The unit of power is watts. Okay? All right. So the important thing is to know your equations. All right. All right. So the sticker on a compact disc player says it draws current 288 milliamperes of current. It is powered by a 9 volts battery. What is the power? The importance here is to make sure this has to be in amperes, not milliamperes. So this will be this will be 0.288 amps. So you have to make sure that the units correspond. If you don't do that, it's going to be incorrect. So once you make sure the unit is correct, you can, you have current and you have volts. So power is equal to VI. So make sure you know all your power equations. Power P is equal to VI. Power P is equal to I squared times R. Power is equal to V squared over R. So make sure you know all your equations. And then you just plug them in and, okay. All right. So question 6, 541 watt toaster connected to household 120 volts outlet. What is the resistance? So again, you have voltage and you have power and you need resistance. So you need an equation with volts, resistance, and power. So if you look at your power equations, the one that you're gonna use is power is equal to V squared over R. Okay, so you just, because you have power, you have voltage, and you need to find resistance. So the equation that I would use is power equal to V squared divided by R. Okay, so you have your power, you have your volt. Make sure your units are correct. So it's in watts, it's in volts. And then, so if you rearrange this, R, which is the resistance, is equal to V squared divided by power. And you plug it in the equation and you'll get your answer. Okay? You have to know your power equation so you know which one to use. Okay? All right, so I think you get that. So we're going to move on now to circuit symbols, because we're talking about circuits and we're introducing some concept, but you have to know what symbols, when you see a circuit, you have to know what the symbols means. So some of the simpler ones, okay, so when we talk about circuits, you have an internal circuit and an external circuit. Your internal circuit is where you have your power supply. Again, the only purpose for this power supply is to give you that electric potential difference. That is to move your positive charge from the negative terminal to the positive terminal. That's your internal circuit. Your external circuit is going to have connecting wires, which going to be straight. It's going to have switch. This is your switch open. Okay. If the switch is open, then the circuit is not complete. The switch should be closed to complete the circuit. You can put an amp meter. This is going to measure current. Your amp meter measures current. And then you start having loads. So for the simple circuit, you have the bulb. That is, you're going to convert your electric energy into light energy. And the bulb is represented like this. If you have an electric motor where your electric energy is converted into mechanical energy, then this is the symbol for that. The voltmeter just measure the voltage. It measures the voltage. A battery. So this is a single cell. The positive is the longest. Is represented by the longer symbol. So this is the positive terminal, the negative terminal, okay? This is a single cell. You can have multiple cells, okay? And then the resistor, remember I said the new symbol for the resistor is on top. This is the old symbol for the resistor. And any electrical device is going to have resistance, and this is how you represent it, okay? And all right. So if you have a circuit, so you can draw a circuit, and or you can construct a circuit and then draw the circuit so that it is understood. So if you look at this, look at the first one here. You have two cells and you have two light bulbs. So which one of these drawings represent that? Okay, this has two cells because the longer terminal is the positive terminal, the shorter one is the negative. So this has two cells. It has two bulbs. Okay, so this circuit is represented right here. Okay. Let's look at this one. All right. So with this circuit now, you have one cell. You have an electric device right here, a motor, and you have a switch. Okay. All right. So this one, you have one cell, the positive terminal and the negative terminal. You have some motor thing, and you have a switch. So, okay, so this one. And then let's look at this one now. This has one cell. What's going on here? So this has one cell. So this one has one cell and two bulbs. So one cell, okay? So positive terminal, negative terminal, and two bulbs, okay? So you should be able to look at a drawing and construct the electrical system, or you can look at the electrical system and make a drawing. Okay, so again, if you look at this up here, you have an amp meter, you have a resistor, you have a battery, and you have a voltmeter. So if you're going to draw that diagram, the resistor is, okay, so this is the old symbol for the resistor, but still resistor. Voltmeter measures the volts across the battery. So you have the battery and the volt. So the voltmeter is going to measure the electric potential difference across the battery. And then the amp meter measure the current. All right. All right. So again, if you have, if you're given this and asked to draw the electrical circuit, again, the battery is represented like this. The larger marking is the positive terminal. The shorter one is the negative terminal. This is a switch which is open. If it's closed, then it should be straight. And then this is your bulb. Okay. Again, if you're given a drawing like this, so of course this is a battery or a power source, and it has 1, 2, 3, 4. It has 4 cells. Okay, it's a power source. This is the wire. This is a resistor. A resistor does mean this is an electrical device. It's another electrical device, and this is another electrical device. This is what we call a series circuit because they're on the same path, okay, so to speak, as opposed to a parallel circuit where they're separated. So you have the same power supply, but instead of all the device in the same path, they're separated. So when the current comes here, some go down here, some go here, and some go there. Okay, so this is what we call a series circuit as opposed to a parallel circuit. Okay, let's we're gonna break here, and then our next session will go a little bit more into series and parallel circuit drawing of circuits. Okay, so let's break here.